that for the system of this inclined plane, the sum of the kinetic energy and the potential energy stays the same. And in physics, we call that being conserved. So this is energy conservation, but it doesn't have the same meaning as the kind of conservation in the sense of turn the lights off when you leave the room. It doesn't have that same meaning. Okay, so you have to be careful. This is another one where we've given something a different meaning. And what it means is the kinetic energy initially plus the potential energy initially equals the kinetic energy final plus the potential energy final. Okay? So, let me talk to you about MGH for a minute. So, if I have a tenth of a kilogram, well, yeah, a tenth of a kilogram mass, and I do work to lift this tenth of a kilogram mass up 1 meter, I've now given it potential energy. A tenth of a kilogram times 1 meter times 9.8 meters per second. So I've now given it 0.98 joules. The unit is a joule of kinetic energy. I mean potential energy. My bad. Now, if I let go of this, what's going to happen? Not a trick question. It's going to fall. Gravity's going to pull it down. What's going to happen to its speed as it falls? Yeah, it's going to accelerate. So it's going to increase its speed, and it's going to lose potential energy and gain kinetic, okay? Until right before it hits the ground, and then once it hits the ground, that energy all gets turned into heat and sound. Some of it gets turned into sound, okay? All right. So, energy units. A girl's favorite unit, a joule. Okay. Not space. All right? And the abbreviation is a capital J. And a joule is, it can be a Newton times a meter. I hope you are keeping track of all the different units and what they go with somewhere in your notebook. It turns out a Newton is a kilogram times a meter per second, per second squared, I'm sorry. So this could also be a kilogram meter squared per second squared. That's also a joule, all right? So kinetic energy and potential energy are both measured in terms of joules. Now this is the key thing that we're testing today. But these other things I think you need to understand in order for this to make sense. So, I've already talked to you about case 1. So, there's a data table there. And the final is the first thing. Wait, it's V initial. That's good. V initial, height initial. That should be in meters. Now, I told you that this block was 0.9 centimeters, so how many meters is that?
What was the number?
0.9 centimeters. How many meters is that? Right. 0.9 centimeters equals 0.009 meters. Move the decimal 2 places to the left. Okay, VI, HI, VF, HF. And then I think I probably have KEI, PEI, TEI. What do you suppose TE means? Total energy. So KEI, that'll be joules. PEI, that'll be joules. Total energy, that's just going to be the sum of these two. Also in joules. And then I have KE final, PE final, total energy final. All right, so here's what's going on. For case 1, experiment 1, you're starting with the glider at rest, so you're holding it before you press collect. You press collect. Remember, you want to give it time for the button to turn red. Then it automatically starts counting time, but it won't measure the time interval until the flag interrupts the beam down here. So your initial speed is going to be 0. And your initial height is going to be the height of this block, which we said was 0.9 centimeters, which is 0.009 meters. And then V final you're going to read from the computer, and it might be something on the order of 0.4 meters per second. You'll know it to 3 decimal places. It'll report it to that. Okay? All right. Now, I'm calling this bottom height, I'm calling that 0. So this end is 0.009 meters above this end. So height final is 0. And that's all you're measuring there, okay? That's it for the first trial. Now, kinetic energy initial, I'm just going to use this one, 1/2 mv squared. So you need 1/2 the mass. Oh, the mass. What mass?
The glider and the flag.
Mass of the glider and the flag. I'm going to say it's about 200 grams. It'll be maybe a little less than that, okay? So, mass of the glider plus flag, about 200 grams. Now, how many kilograms is that? 0.2, very good. So, your kinetic energy initial is 1/2 m times V initial squared. Well, what was V initial? 0. So, really, no calculating here. Potential energy initial? Potential energy is mgh. So, mgh initial. This is not 0. So what do we have? We have 0.2 times